Welcome back to AI Codecast. Today, we're going to be diving into a problem that, well, it might seem deceptively simple at first. How to load a truck with boxes to maximize the total units that it's carrying.
Yeah, this is like a classic optimization problem that you see everywhere, from logistics and shipping to, even something as relatable as just like moving.
Oh, absolutely. Imagine you're moving and you've got this limited space in the truck. You wouldn't just be tossing boxes in there randomly, right?
Yeah.
You want to prioritize like the ones with the most stuff in them.
Exactly. And that's really, that's where the challenge lies, right? You have all these different types of boxes. Each one contains a specific number of units. And your goal is to like figure out the best combination that gives you the most bang for your truck space buck.
So where do we even begin with a problem like this? I mean, I'm guessing there's more to it than just, grabbing the biggest boxes first.
Yeah, you're right. It's not quite that straightforward. Um, One approach, could be that we try every single possible combination of boxes. We call this the brute force method.
Okay, so brute force,
Yeah.
we're essentially trying every key on this like giant key ring until we find the one that unlocks the door. We're checking all possible solutions, which, I mean, sounds simple enough. What's the catch?
Well, the catch with that is efficiency. Or, well, I guess you could say the lack thereof. Imagine you have, hundreds of box types. Checking every single combination, it would just take forever.
So brute force works.
Hmm.
It works, but it's not the most, I guess, elegant solution or even practical,
Mm.
especially when you're dealing with a large number of boxes. There's got to be a smarter way, right?
Yeah, think about it. What if we organize the boxes first?
You mean like sorting them based on the number of units they hold? So like kind of like if you were arranging books on a shelf by size
Hmm.
to fit more in.
Exactly. Sorting allows us to, be a bit more strategic with our loading process, right? So if we arrange the boxes in descending order of units per box, then we can start loading with, the densest ones first. And this is where a greedy algorithm comes in.
Okay, I'm starting to see the light here. So instead of, just aimlessly grabbing boxes, we bring some order to the chaos, right?
Yeah.
We sort them and then we greedily pick the ones that give us the most units at each step.
You got it. And the beauty of sorting is that it significantly improves the efficiency compared to that brute force approach. But
Yeah.
but before we get too excited, there's a nuance here with this greedy approach that we need to consider. It works best when we can take fractions of box types.
Fractions of box types. So we're assuming we could split a box
Mhm.
and then just take like a portion of its contents.
Precisely. And this is where, the analogy of the moving truck might kind of break down a bit, right? Because you
Ah.
can't really take half a couch or a third of a bookcase.
Oh, that makes sense. That makes sense. So this sorting and greedy approach, it works great when we have that flexibility.
Right.
But I mean, in reality, we often deal with scenarios where, you either take the whole box or you leave it.
Exactly. And that kind of takes us into a whole different territory, which we'll explore in the next part of our deep dive.
This is already getting me thinking, so stay tuned, folks. We're just getting warmed up. We'll be right back with more AI Codecast after a quick break.
Welcome back to AI Codecast. So before the break, we were talking about how that sorting approach, it works great when you can take those fractions of box types. But what happens when we can't split the boxes?
Yeah, that's where things get a bit trickier. It becomes kind of like that, that classic knapsack problem, right?
Yeah.
Where you're a hiker, you've got this limited size knapsack, and you have to choose which items you're going to pack
Mhm.
to maximize the value that you can carry without, going over that weight limit. So instead of neatly arranging those books on a shelf, it's more like trying to fit like these oddly shaped pieces of luggage into an overhead compartment on a plane.
Yeah.
You can't just you can't squeeze in like part of a suitcase.
That's a perfect analogy. When we can't take those fractions, that greedy algorithm with the sorting, it might not give us the absolute best solution. So we need a way to explore different combinations of whole boxes to see which one really maximizes the units.
Hmm. So how do we go about exploring all these combinations? Because I mean, it sounds like it could get pretty messy.
It can, but there's a systematic way that we can do this using a technique that we call backtracking. Imagine we're building this like decision tree, right? And each level of the tree it represents a different box type.
Okay, so I'm visualizing this tree. It's got all these branches, and at each branch we have to decide, okay, are we going to include that box type or not?
Exactly. We start at the top with, with an empty truck. And for that first box type, we've got two choices: include it or exclude it. And each of those choices, it creates a new branch in our tree.
So we're kind of simulating both possibilities. It's like we're playing this game of, like, what if? What if I take this box? What's the best I can do from here? And what if I don't take this box?
Precisely. And we keep making these choices for each box type, going deeper and deeper down that tree until we've considered all of the possible combinations. And each path from the top of the tree to the bottom, it represents, a unique set of boxes that we've chosen.
And I'm guessing, like, at each step, we're also keeping track of the total units that are loaded and, like,
Yeah.
how much truck capacity is remaining.
Absolutely. We need to make sure that we don't, exceed the truck's capacity as we're exploring these different branches.
So it's like navigating a maze where each path, it might lead to a different outcome, and our goal is to find the path that leads us to, the treasure chest with the most units.
Exactly. And backtracking, that's our strategy for navigating this maze. We explore a path, and if it hits a dead end, like if we exceed the truck's capacity, well then we backtrack, to the previous decision point and we try a different branch.
This all makes sense, like, conceptually.
Yeah.
But how do we actually translate this backtracking idea into something that we can code?
Well, think about it this way. We can use a recursive function. Let's just call it maximize units. And this function, it takes the current box type, the remaining truck capacity, and the current total units as input.
Okay, so this function, it represents, like, our position in that decision tree. And it tells us which box type we're considering, how much space is left, and how many units we've already loaded up.
Right. Now, inside this function, we first check if we've reached the end of, our list of box types, or if the truck is completely full. And and if either of those things are true, then we stop, right? And we return the current total units because there's nothing more we can do on that path.
So those are like our stopping conditions, our base cases.
Exactly. Otherwise, we've got two choices to explore, just like we talked about, right? Include the current box type or exclude it. And for each choice, we make a recursive call to maximize units, but with updated parameters based on our decision.
So if we choose to include that current box type, we update that remaining capacity and the total units based on how many, boxes of that type we can fit.
Right. And then we make that recursive call with the next box type index.
And if we choose to exclude it, then we just simply move on to that next box type in our list.
Precisely. And the key here is that we're essentially trying out both options, right? And comparing the results of those recursive calls to see which path gives us that higher total unit count.
So we're keeping track of the best result that we found so far as we explore all the different branches of our decision tree. It's like trying all the different routes on a map and comparing the estimated times of arrival to find the fastest one.
That's a great way to put it. And while backtracking can be, computationally more expensive than that sorting and greedy approach, it it does guarantee that we're going to find the absolute optimal solution, even when we're dealing with those pesky whole box constraints.
This is quite the deep dive into the world of optimization algorithms. I mean, it's
Yeah.
it's amazing how we can use these techniques to solve, like, these really practical problems.
And the applications, they go way beyond just loading a truck. I mean, think about things like resource allocation, scheduling, even things like, optimizing your investment portfolio.
That's what makes this so fascinating. But for now, let's maybe shift gears a little bit and talk about, where these algorithms are being used, like in
Yeah.
real world scenarios. I think I think our listeners would love to hear, like, some concrete examples.
Absolutely. And that's exactly what we're going to be exploring in the next part of our deep dive.
Welcome back to AI Codecast. We've been exploring how to, maximize units on a truck. We've talked about everything from simple sorting to that more complex backtracking approach. Now I'm kind of curious, like, where are these techniques actually being used out there in the real world?
Well, I mean, think about, companies like Amazon or FedEx. I mean, they handle millions of shipments every single day, right? And for them, efficient packing, it's absolutely crucial. I mean, for minimizing costs, delivery times.
That makes sense. I mean, every inch of space has got to count when you're dealing with that kind of volume.
Exactly. These companies use, these really sophisticated algorithms, often based on, the techniques that we've been discussing here, to determine like the optimal loading strategy for their trucks, their planes. And it goes beyond just, fitting things in. It's about, prioritizing packages, managing weight distribution, and even planning routes efficiently.
So these algorithms, they're not just about cramming as much stuff in as possible. They're considering like a whole bunch of factors to just make the whole logistics operation run smoother.
Precisely. And it's not just limited to, delivery companies, right? Imagine you've got like manufacturing plants, right? They need to transport raw materials. Or even moving companies, right? Trying to fit all your belongings into a single truck. I mean, optimization, it's everywhere.
It is fascinating how these algorithms are working behind the scenes
Hmm.
to make so many aspects of our lives more efficient.
And the impact, like, it goes beyond just efficiency. By optimizing logistics, we can reduce fuel consumption,
Mhm.
minimize the number of trips that are needed, and that contributes to a more sustainable approach.
So it's a win-win, saving money and being environmentally conscious. That's impressive.
Indeed. And with the advancements that we're seeing in AI and machine learning, these algorithms, they're becoming even more sophisticated,
Right.
more adaptable. So I mean, we can really expect to see, some even more dynamic and even more efficient solutions, down the road.
That's exciting to think about. But let's bring it back to our listeners for a second. What if someone is thinking like, okay, this is cool and all, but how can I actually use this knowledge?
Well, I mean, even if you're not working at, at some logistics giant, understanding these concepts, it can be incredibly valuable, for aspiring developers tackling this problem. It's a fantastic way to practice implementing algorithms.
It's like a coding gym workout for your brain.
Exactly. And even if you're not a programmer, understanding like the principles of optimization, it can be helpful in everyday life, right?
Oh,
Packing for a trip, organizing a closet, planning a project. I mean, these all involve maximizing efficiency in some way, right?
so it's about applying like computational thinking
Right.
to make better decisions in all these different aspects of our lives.
Precisely. It's about breaking down, complex problems into smaller steps,
Hmm.
identifying patterns and finding, these creative solutions.
Well, I think we've covered a lot of ground today. We started with this pretty simple problem, how to load a truck, and we ended up exploring these fascinating algorithms and their real world applications.
It is amazing how, a seemingly straightforward question, it can lead us to such, these profound insights.
Indeed, and for our listeners, whether you're a seasoned developer or you're just starting, your coding journey, we hope this deep dive has sparked your curiosity and given you a new perspective on the power of algorithms.
Thanks for joining us on AI Codecast
Yeah.
at